In this section 7.2, what we're going to do is focus a little bit more on the domain and range. So let's look at their definitions, and then we'll go take a look at some situations and slowly start building how we represent these sets. So again, a domain is a set of inputs that produce an output. So our function is an input-output system, so whatever values we can put in represents our domain. The range is a set of outputs created by the function inputs. So as we input everything, things come out. The set that comes out is our range. A set, all right, so the definition of a set is very important here, but a set is a collection of objects having the same thing, something in common. So for example, our domain is a set because what's in common is they're all inputs producing outputs. The range is a set because it's a collection of objects that are created by all those inputting. All right, so we're trying to find a collection. And it turns out that there's two different types of sets that we have. The first type of set is called the discrete set. What we have in a discrete set is the data is isolated, they're unique, they're singular, whatever the case might be. So when you take a look, here's an example of an x-axis, if you would, and I have 4 distinct dots. So what I'm representing here is -4 is a distinct dot, -1 is a distinct dot, +1, and 5. And what we usually do is we use curly brackets to represent the set. So this picture only describes 4 pieces of isolated data. I'm not talking about everybody in between. I'm just talking about the number -4, the number -1, +1, and 5. So what we have is a discrete set. Now that's how we normally write it. We can even do that on the y-axis. So for my y-axis here, again, there's actually 3 dots, one represented at -3, one at 0, and one at 3. So using my curly brackets, on the y number line here, there's only 3 values, 3 isolated, unique, singular values, right, that are in the domain. And when we put it together in a function, here's a picture of a function. It obviously passes the vertical line test. And you're looking basically, now that we're looking at, rather than 2 things separate, we're looking at them together. But it basically comes down to just looking at the x-axis. So when I look at the x-axis, right, we can see that -4 is in it, -1's in it, +1's in it, and 5. So the domain would be -4, -1, 1, and 5. Because those are the only 4 values where there's an output. And then if we look on the y-axis, right, 3's covered, 0's covered, and -3's covered with the data points. So my range is from -3, 0, and 3. So that's what it would look like individually as discrete, and this is what it would look like if I put it together in a function. So again, we're just looking at what's happening along the x-axis, what x values actually have a data point associated with it, and we're looking at what y values actually have a data point associated with it. So I kind of call it like we're covering, this point covers the x-axis at -4, right? It covers the y-axis at 3. So 3 is in the domain, or excuse me, the range, and -4 is in the domain respectively. So where are we covered? Another type of set is what we call an interval. An interval is everything between 2 different numbers. And so apologize for that dot there, but notice here I have, we're talking about -4 to 5, but the numbers are isolated and distinct. Here it's different because I am talking truly about everything from -4 to 5, and I'm shading everything in between. So all our fractions, all our decimals, everything between these 2 numbers. So we usually use interval notation to do this. Interval notation, you begin with what's bounding the set to the left, so that's -4. What's bounding my set to the right, that's 5. And since we're included, we use brackets. All right, if they were open circles, we'd use parentheses, and we'll practice that in another video. But there you have it. So this type of notation, notice we're not using the curly brackets, but this type of notation is indicating I have an interval. We're talking about the number -4 and 5, we're including those, and then every single number you can possibly think of in between. Same thing along the y-axis. Again, we have -3 and 3, but because I shaded everything, we're talking about everything in between. So the set here would be what bounds me below -3, what bounds me above positive 3, since we're including those boundary points, I'd have brackets, negative 3, 3. So this interval notation indicates that we're talking about all values between negative 3 and 3 and including those two values. So putting it together in a function, again, I have a function that passes the vertical line test very well. So what covers the x-axis? Well, we're basically talking about everything from negative 4 and all x values. Notice we have a nice solid line. So all x values up to 5 are covered basically by the function. They all have some y value associated with it. So the domain would be negative 4 to 5. The range, well, we look again, right, what's covering the y-axis? Well, the graph basically starts from negative 3, and we have y values being outputted all the way to positive 3. So the range in this case would be negative 3 to 3 in interval notation. So how about we cut this one short? Let's do some more examples where we practice discrete sets and interval sets with regards to number lines and XY grids.